last week, IBM announced a series of new products called the FlashSystems storage that are a result of their acquisition of Texas Memory last October. In addition, they're opening 12 global competency centers around the world to help companies to evaluate and adopt this technology, and an investment of $1 billion over 3 years in additional R&D in the flash area. So why is this significant? Flash, first of all, is fast memory. All right? It's solid state. There's no rotating mass. There's no startup time. It gives you instant on, instant access. There's no real latency for different parts of the memory, which is what you would have in rotating disk. With a rotating disk, you've got an arm that comes in and out, so it takes longer to get from outside to inside the platter, going from one platter to another. There are different times, and what we've had to do in the past to get around that is a lot of kludge work. So this is a very direct, fast approach. But the big thing here is that it's now becoming the economic best choice and not just the best performance choice. And a couple of bullets here describe that. It requires lower energy by far than rotating disk. All right, you've got no moving parts. Lower space requirements, and lower application license costs. That's something that most people don't take into account. If you're dealing with applications that are licensed per server or per core, with Flash you require fewer cores to get the job done. So our friends at Wikibon actually have a number of performance improvements that they've documented. 38% lower software licensing fees because of the core issue. Up to 50% higher storage utilization, and 17% fewer servers, which results in a smaller footprint, less real estate required. And that may not sound like a lot, but if you're going from 315 racks per petabyte to 1 rack per petabyte, you've just saved yourself a couple of rooms, and all of the energy costs that go along with that, the real estate costs, the heating, cooling, etc. It's a huge difference. So what we see right now is that it's clearly the memory of choice, or the technology of choice for applications that have a lot of I/O per second. Flash is already there. What's interesting is that with these new announcements and with the new packaging, the new bundling, the new research that's going into it, they're driving the cost down, driving the performance up, and making it appealing for other types of applications. The other part of the intrigue with Flash for me is that it makes system design and implementation a lot simpler. It brings it closer to the problem statement than to the limitations of the architecture itself. So it's not just about memory. It eliminates a lot of those workarounds I started to talk about with hard drives. You don't need to worry about whether something is placed at the edge of a disk, because at the edge of a disk you've got a higher speed, so you're getting faster access. You're not wasting the inside of a disk if you have really high performance requirements, because wherever something is in flash memory, it's the same time to access it. So it's not just a faster solution to old problems. It actually will facilitate or enable us to go after some problems that previously were just too tough to handle given the architecture using hard disks. So Flash fits our ABC criteria at Storm. We've talked about this before, that when we look at new technologies to see if they're disruptive or if they help in a disruption in an industry, we look at 3 things: abstraction, binding, and complexity. And what we'll see is that Flash scores well on all of these. So here's a chart I use to demonstrate how different technologies fare in terms of increasing abstraction while reducing binding time, or delaying binding time. What we see is the worst case, things that have very low abstraction and very early binding, machine language, right? That's the basics, okay? You're doing everything based on the limitations of the machine, so you have to make early decisions about how storage is allocated, how registers are allocated, detailed stuff. As we start to move higher up and we get higher level programming languages, then we start to cross into this upper quadrant and have things like virtualization, cloud computing, which help in both of these. And I'm putting Flash in that same category. The reason is simple. With Flash, you don't need to think about limitations of the memory when you're designing your application, when you're designing your system, because it's all the same. You don't have to think, is this tier 1, is this tier 2, how do I get things as fast as possible in low latency? So it lets you think at a higher level and defer those decisions until closer to execution time. And that is a huge benefit for system design. At the IBM announcement, one of my old colleagues reminded me that I've been negative over the years about the ability of hardware to differentiate one business from another. Because typically you're buying things off the shelf, and even if you're configuring them to your own environment, everybody has access to the same hardware in general. Typically, if you want to add new differentiating capabilities for your business, you'll create some special software or special use of the software, or look at your data differently, analytics at the high level. Things that get repeatedly used at the high level tend to migrate down. So common functions, we used to have separate spell checkers in our spreadsheets and our word processors and our graphics programs and whatever else we were using. Now those common elements get filtered down. Some things go all the way down into hardware, like security. There are a lot of security things that started out at the application level, went down into the OS level, and now are actually in hardware. So in general, the migration value is from the top down. But when you have a technology like Flash that is truly disruptive in its ability to facilitate things at the high level, you can actually get that competitive advantage by updating your platform at the low level. It still gives you the value based on performance or on new functionality at the high level, but for a period of time, the early adopters with Flash are going to have a serious advantage over people who take too long to make the move to Flash technology. So what are we going to do about this? IBM, in their announcements and their articles, are calling this the tipping point for Flash, but I think it goes beyond that. So it's kind of a cliche, but I think it's a flashpoint for all of IT. The issue here is that if you change a fundamental assumption about your architecture, about your ability to have common speed for retrieval of data across your entire storage portfolio, forgetting about backup at this point, it changes what you can do and how you think about things. So our recommendations are, if you're making any new significant investment in IT, make sure that you evaluate Flash technology to see if now's the time for you. If you have things that you've looked at in the last couple of years and discarded as new applications because of performance constraints, take another look at them and see if this actually changes things. And finally, really focus on training your analysts, your designers, your programmers to think Flash first, because that's where we're going. It's already time right now. If you have certain types of applications, it's a great time to be adopting it. And if it's not right for you today, there's a good chance it's going to be right for you in 18, 24, 36 months. So your people should be looking at it right now. That's where you're going to get the benefit. Make sure that you have the right applications at the right time on the right platform.